I usually get the similar results or similar enough that I'm comfortable with it. So, but I'm saying I do have issues with getting the same scan, exactly the same scan always. So, then if you are adding a coverage tool, that adds significant overhead. So, sometimes it takes me a while to get the application stable once I add the tracing coverage tool to it. So there's that. And sometimes the scanner logic works really well on one application and is completely ineffective on another. I mean, this isn't true for all scanners, but it's true for some, and maybe most actually. But so sometimes the scanner will do really well on one app, and then another app it'll find nothing. Also, if the application has really poor error handling, you're gonna have a lot of problems. Scanner depends on how good the scanner is in recovering, and some scanners will just stop. You know, if it doesn't like what the application is telling it, or if it's getting too many errors, it'll just shut down. So that experience also. Comprehensive scans take a long time. I mean, sometimes it's as long as 8 to 12 hours if it's a really fairly large application with a lot of JavaScript and stuff. I haven't had good experience with portlets. I don't know if anybody here scanned a portlet-based application. Yeah, I haven't had. Actually, the results are unusable. Actually.
What do you attribute that to?
I don't know. I'm not sure. I mean, probably somebody else in here might know.
We're trying to figure it out, but they just fall over.
Right. Yeah. I was actually testing. I was going to try to test a portlet application for this presentation, but it was not possible to do. So that's interesting. So that's the thing. You know, when you're using a web app scanner, it may not work on your application. You know, that's why you really want to test it before you, especially if you're purchasing something, make sure it actually works. And then sometimes vendors especially vendors don't like it when you're comparing scanners and then you want to talk about it with a lot of people. So that's another issue that sometimes comes up.
Is that why Sensic and HP are not in your evaluation?
Exactly. Yeah. So these are the applications I used in the benchmark. Yeah, we'll see. I haven't talked to the Acunetics yet. We'll see what they have to say. So I used I have more results than this, but for this particular set of results, this is what I'm going to present: Apache Roller 4.0, and another Java application, which is an extreme programming. That's not really a portal, but it's like an extreme programming kind of management application where you can set up your stories and put all your users in and how they work together and all that stuff. It's an interesting app. And it's got tons of JavaScript and all kinds of junk in it. I used Fortified Tracer 2.0 for coverage analysis. Yeah, so I focused on Java applications, so I could use Fortified Tracer. Now, actually, I'm going to start working on some .NET apps. So I finally got my environment to the point where I can start doing .NET apps. So that's coming, and Fortify supports .NET also, so I'll be able to have some results on that also. These applications, they had some meat to them, and they were not that complex, and the scans could go through fairly smoothly. And then yeah, they played well with the tracing application, which isn't always the case. That's my server environment. It's AMD 64, Debian Linux 9 in Zen virtualization, Sun JDK 1.5, and MySQL 5.0. So I'm going to talk a little bit about trace analysis. And there's two types of trace analysis. Static weaving and load time weaving. Actually, in the first paper I did, I used static weaving, where the code's added to the application, and you have the compiled binary or bytecode in the Java case, and then the weaving application will add the monitoring code to the bytecode. Yeah, so it's actually I use post-compile weaving for the last one. And then there's load time weaving, which I used in this one. Load time weaving is kind of interesting. So It is the same as post-compile weaving, except it's done as the classes are loaded into the virtual machine. So, and one interesting thing about it, I noticed, and with this load time weaving is when classes are loaded, sometimes other supporting classes are loaded too. So you'll the environments will have new what would I call it? It'll add code to stuff that when you initially loads up, you'll have a certain amount of code that was added as monitoring code, and then suddenly you'll have more. As more classes are loaded, you'll see it appear in the 4.5 console. There'll be like maybe 200 or 300 more endpoints that were added. So it's interesting that it's kind of this dynamic thing. And that's basically what happens. You have the class file, and then you have the methods, and the aspect is actually the monitoring code, and it sits. It's compiled in there, and depending on how it's coded, it's capable of grabbing the data before the parameters before it enters into the method, after it enters into the method, or both. So it's able to operate on that. And usually, what happens, what I've seen is, they'll put some regular expressions in there or some other type of logic to try to detect not only if that was actually triggered, but is there even a vulnerability in there? So the tracing tool actually is able to actually discover some of the vulnerabilities. So I think actually this is for at least for bytecode based applications, this is kind of like the beginnings of a possible internal application based security system. And I think that's going to be coming down in the future. Just some of my observations. I think in the future, I think security systems probably will be inside the application rather than outside. I think that's where it has to go, rather than sitting in front of it on a network. Okay, so here's some of the first benchmarking statistics I have. This is for the XPlanner app, and this is a little bit about what I discovered. So, so for NTO, 249 links crawled. Now, here's a strange thing I don't know about AppScan. I actually, this was for the last scan I did. I actually initially got more links crawled. The first test I did in less the second, but the results were the vulnerabilities found in the results were exactly the same. So, XSS found 30. SQL injection 1, false positive 5, false negatives 2 for AppScan, NTO 14, SQL injection none. No false positives though on this one. That was interesting. And false negatives 19. And the reason I put a star on W3F for links crawl is because W3F can't automatically crawl JavaScript and Flash, Flex. You have to actually do all that manually. So you have to manually crawl the application, and then based on that, it's able to process the JavaScript. It's a little strange, but that's how it works.
What was the actual number of vulnerabilities?
That's the actual number. Okay, 14 and 31.
Yeah, the actual, not what the scanner, how many existed?
Oh yeah, well.